The subject of my presentation is multi-cloud content workflows, leveraging the unique characteristics of cloud. And for those of you who don't know ASPERA, we're a software company, and we provide a software solution for high-speed file transfer. And I'm going to talk about the challenges that our customers face and the technology we provide to help them move their data around. A little bit about me. I'm the Director of Cloud Platforms and Services at ASPERA, where I've worked for over 10 years to help our customers understand our technology and help our engineers understand the needs of our customers in a market. In addition to being a technology professional, I'm a parent, of course, where I explain to my child not just about the needs of today, but the possibilities of tomorrow. And I love combining being a technology professional and being a parent because the conversations are often very similar. When I talk to customers, it's not just about the problems they have today, but it's also about the possibilities of tomorrow. And when you spend time talking to people, especially about data transfer, you realize that they're human, and like most humans, we don't do well with certain types of calculations. So a little story about that. I was recently traveling overseas on a long trip to present in Europe. And when you take a plane to Europe, it takes a 10-hour flight from San Francisco to London, for example. And that makes sense. I mean, it's 5,000 plus miles. You're going 500 miles per hour. So roughly, it's a 10 plus or minus hour flight. And the human brain works that way. We were wired, of course, to understand velocity because in the savannah, you knew how fast you had to run to catch the gazelle so you could have lunch. And you also knew how fast you had to run to avoid being caught by the lion so you were not their lunch. So we understand velocity. But when it comes to other equations such as transfer rates, which is the world we live in, the human brain doesn't always seem so well equipped. For example, ask yourself the question, if you had to move a gigabyte of data over to London, how long does it take? How long would it take? Probably you don't do it every day, so maybe you don't have the answer at your fingertips. But I bet you'd have to spend a few minutes to try to figure out, with a 100 megabit connection, how long would it actually take to move that data? We'll come back to that later on. So the challenges really are multi-part. One challenge is the volume of data that we're dealing with in the media workflows continues to explode. The formats of the data expand, and the need for moving that data continues to grow. The other trend we're observing, of course, is that the media industry is, for the most part, moved off of physical-based media onto digital media production and delivery systems. And now is starting that journey from an on-premises world of producing and distributing and transforming those digital assets to a cloud-based world. We've been watching this transformation for 5 years, and I really can see we're still very much at the beginning. And the types of workflows organizations are doing, initially was simply migrating the data up to a storage platform where they can store it off-site, for example, or perhaps build a transformation platform where you can transform the assets or leverage a service that's doing transformation for you, or perhaps deliver content from that location out to customers or partners. And now more and more, we're starting to see the beginning of true production in the cloud. So the use cases migrate over time, but they certainly continue to grow. The challenge, of course, are that when you're trying to move your data to your customers, to your partners, from your customers, to a system where you're going to store it, to a system where you're going to process it or manage it or refactor it or redeliver it, the movement of that data over long distances is challenging. The options for moving data historically have been shipping disks. That's really no longer acceptable in today's ultra-fast world. Providing dedicated network infrastructure is also not so practical in a world where you have to deliver to and from partners all over the world that change all the time. Running your own servers to be able to send or receive the data is also challenging operationally, and organizations are trying to get away from that. What organizations continue to press us for and what organizations continue to need are systems for delivering data at the multi-gigabit per second rate. The ability to support ultra-large data sets. And I say that generously, for a small, mid-size office, an ultra-large data set could be hundreds of gigabytes or terabytes. For a very large organization, hundreds of terabytes of data. And we have organizations now that need to move petabytes or multiple petabytes of data monthly or annually. What organizations also need for their business is predictable delivery times. You can imagine, it's not so hard to imagine why FedEx is so successful in the delivery world, because they guarantee overnight delivery. There's a need in the market for digital guaranteed delivery times. Of course, the assets that organizations are moving are high value assets. It's their intellectual property. So the ability to deliver that asset, move that asset securely is for sure an important aspect of any transport system. And if you're in the business of moving lots of data, or your business requires that you move lots of data, the ability to automate it through APIs and through management systems and through purpose-built applications actually also is quite important. And as we move to the cloud era, where everything is being offered as a service, the ability to consume a delivery technology as a service is also very interesting for many organizations. So what we've done at ASPERA over the course of the last 14 years is created a unique delivery technology. It's a core protocol that enables organizations to move their data over public networks as fast as the infrastructure will allow. Let's go back to that example. That question I asked earlier is how fast should it take to deliver a 1 gigabyte file, for example, over to London? You probably have dragged and dropped files around your office to and from your local server, but you probably have not attached a gigabyte file to your email to send it to a colleague in London. And you may have used an FTP server to do it, but it's kind of slow. You know it's slow. How long should it take? Is it an hour? Is it 30 minutes? Is it 10 minutes? What would you guess? Take the example of a 100 megabit per second line. And remember, a 100 megabit per second line allows you to move 100 megabits per second. That's megabits. That's a million bits. That's a lot of bits. But if you use that line to move a gigabyte of data, how long would it actually take? You have to do some translation, of course. You have to move bits and bytes to convert them. Maybe you have to convert seconds to minutes or hours. Let's go through the example. 100 megabits per second, to convert that to bytes, you divide by 8, of course. So you have 12.5 megabytes per second. So in the course of 1 minute, you multiply by 60 seconds to convert that to minutes. So you have 12.5 times 60, 750 megabytes per minute. Think about that for a second. So my question about moving a gigabyte of data over a 100 megabit per second link should take just a little bit more than a minute, right? 100 megabit per second link is no longer really considered fast. People have that in their home office these days, yet nobody stops to think, why does it take 10 or 15 or 20 or 30 minutes or hours even sometimes to move that gigabyte of data around? And the answer is because the protocol that's used to move data today on the public internet wasn't designed for the internet that it's operating on. It's a great protocol. It does a wonderful job at moving lots of data, lots of types of files. However, when you put it to work to move bulk data, and the gigabit is a very small amount of data in the world we live in, but imagine you had to move hundreds of gigabytes or terabytes of data or petabytes of data, it's really no longer practical to do with the standard protocols that are used today. And for those of you who haven't already guessed, the protocol I'm referring to is TCP. So that's the basic challenge that organizations are faced with, is the standard software tools used today for moving data isn't sufficient for moving the volumes of data over the public internet, over the type of networks that organizations want to move data. So the founders of ASPERA created a new innovative protocol that enables you to leverage the entire available bandwidth. So my example of a 100 megabit link moving a gigabyte file is very true and very easy to do. However, organizations today have much faster than 100 megabits. They have gigabit network connections. In the LA basin, they now are pushing 40 gigabit per second network connections. So in a gigabit per second world, how fast would it take to move that 1 gigabyte file? It's actually 1/10 the speed of moving it over a 100 megabit link. So instead of 1.5 minutes, 90 seconds, you're down to like 9 or 10 seconds. And that's actually possible if you use the right protocol. And what we've done is taken this technology over the years, is packaged it up and made it available for organizations to use to move their data. And as those organizations' data volumes grew and networks grew, we expanded the capabilities of the protocol and the application stack to allow them to automate and to monitor and manage and control those transfers. And as those organizations wanted to move data up to cloud platforms, we enabled the protocol to work well on the cloud platforms. And today, if you explore our offerings, you'll discover that we support transfers to the Google Cloud Storage, to the Amazon Cloud Storage, to Azure Cloud Storage, and more recently, of course, we've added on the IBM Cloud Platform. And moving data to those storage platforms presents another unique challenge. If you've studied object storage and the way you move data into and out of object storage, it's a little bit different than the traditional file systems that you're probably used to on premises. They have a single API. It's an HTTP API, which is a great protocol, by the way. I'm not knocking HTTP, but if you're trying to move a lot of data into and out of object storage, you will be encumbered by that HTTP protocol, especially over the long distance. So the cloud, while it presents so many great capabilities and so many attractive features, it creates one specific bottleneck, which is the ability to move large volumes of data very quickly up to the storage platforms. And again, the protocol that was created by the founders of ASPERA is uniquely designed for that particular problem, the ability to move data over long distances, over any type of network. And what we do in the cloud platforms is integrate our transfer protocol with the APIs required to read and write data to object storage, so we can move data from your on-premises location directly up into the cloud storage. Not only do we have a protocol that's capable of doing it and an application stack that we provided for years, because of customer demand, we have transitioned into offering that as a service. And that's essentially what we're talking about here today, is providing a service on the public cloud platforms that enables organizations to move their data to and from their own object storage so they can in turn store, archive, transform, redeliver the assets that they need on the cloud platform. What are the advantages of a service like this? Performance at any distance. That's a key one that most organizations recognize. They need to move more data more quickly, so the idea of moving data quickly is very attractive, and they're very aware of that pain point. File sizes, the ability to move large file sizes, large sets of files. Again, whether it's multi-gigabytes, multi-terabytes, or multi-petabytes of data. And on the other end of the spectrum, the ability to move small directories and small files. It's another type of challenge, not so much in the bulk data, but in the ability to manipulate, identify, and to compare the metadata associated with the small files. The ability to do all of that in a very fair and friendly way. Again, in a laboratory, it may not be so hard, but in the real world, where you're receiving data from or sending data to a multitude of sources and destinations, you need to be able to correctly identify the appropriate transfer capacity of that network connection, the appropriate transfer capacity of the storage system that you're writing to so you don't overdrive the storage, the ability to monitor and control the transfer speeds on the sending and receiving side. So the ability to control the bandwidth turns out to be a critical element of the solution. And of course, for anybody that's moving large data sets, we know networks aren't perfect and storage systems aren't perfect, and there are occasionally hiccups, occasionally entire regions go down. So the ability to automatically pause or resume a transfer, and of course, encrypt that asset as it's being delivered, or maybe even encrypt it so it lands on the disk fully encrypted, either with a client-side passphrase, or perhaps a server-side passphrase, or perhaps even a passphrase provided by the cloud platform. And to be able to do that in a highly concurrent environment with a platform that can automatically scale up to meet the demands of the file transfer system, and to offer an entire set of APIs for monitoring, transfer initiation, transfer authorization, file system operations for scanning, searching, deleting, and creating folders. The platform we deliver looks like this. This architecture represents cloud storage in the large yellow box. Sitting in front of that cloud storage is a cluster of live servers where data is transferring through the servers, and the colors indicate, the level of load or capacity on those servers, whether they're fully utilized and currently consumed, or if they're available for taking on additional load, or they're available to scale out on demand. And on the other end of the spectrum are a variety of clients, software client options for initiating transfers, whether it's a command line client, or a desktop client, or a mobile client, or a browser plugin client. And the service is currently available, or soon to be available, at a global scale. We are focused on the top 4 cloud providers and have a customer live already on the service and evaluating usage of the transfer platform in all regions of the world. And for those of you that already use ASPERA as a technology in your organizations, you can leverage your existing ASPERA software together with the service. We spent a lot of energy to make sure it was fully compatible with our existing product line. So whether you have existing ASPERA clients or servers, those can seamlessly interact with the transfer service. If you're already considering our SaaS solutions, this SaaS solution now, the ASPERA files, can be expanded out to the cloud provider of your choice, to the storage, your own cloud storage. It, of course, is a platform, and as a platform, it has APIs and can be integrated into your own web application. We have many asset management organizations and delivery and service providers that are embedding ASPERA transport into their services. And of course, if you use one of our existing web applications, those can also be attached into the transfer service to enable you to scale out to the cloud. Here's a simple diagram representing the basic transfer for uploading and downloading in perhaps a data migration scenario. On the left, we see a software client. On the right, we see the destination, the object storage, and there, also up in the cloud, is the transfer service. It's very simple. Take a file like an FTP client, transfer it up. We can expand beyond that and enable a web application, such as our files or any custom web application, to access the APIs available in multiple clouds attached to multiple different storage systems. And in this diagram, we're showing a combination of on-premises transfer systems and storage and cloud-based transfer systems and storage. And we support all of them, whether it's, again, Amazon, Azure, Google Cloud, IBM Cloud, and anybody that has ASPERA technology already deployed in their on-premises data centers. Thirdly, we have some examples of APIs where organizations have built custom applications. Again, I alluded to asset management systems, custom delivery systems, custom transformation systems for encoding or transcoding services. They can leverage the native REST APIs on the transfer platform for requesting authorization, for monitoring status of transfers, for controlling the status of their transfers, or reporting on the success of a given session or file. And all of this is provided on a spectrum of infrastructure, whether it's customer managed and customer deployed in an on-premises world, or perhaps a customer managed or deployed in a cloud environment, or all the way on the other side of the spectrum, an ASPERA managed and ASPERA deployed sets of applications and services. And lastly, the transfer service is available to support all of our existing web applications and management systems and automation systems, such as the orchestrator workflow engine, the console monitoring and reporting, and a configuration application, or our traditional shares or fastpacks applications. And it's available today for evaluation. So if you find that you're interested or would like to explore further, you're more than welcome to come and take a look and give it a try, kick the tires. Thank you so much for the opportunity to present.